Good afternoon to all of us. At this time, let me thank you for the willingness of Mr. Humasak Tommy Argos Simanjuntak and Mrs. Parmonangan Tugatorop as our examiner, and especially to Mrs. Junita Amalia as our supervisor, so we can conduct this final project seminar. We are from TA3 Group, and our final project title is Classification Model of Fake News using Bidirectional LSTM and Word2vec as Vectorization. Chapter 1. This is the following parts that will be described in Chapter 1. The first is research background. The distribution of information through online media is done not only by well-known news sites, but also can be done by all internet users without going through any checks. Some information that distributed individually or in groups cannot be justified, and this problem reached 1,000 of people. Based on the research background, we want to build a classification model that help to classify a news as factual news or fake news. To create the classification model, we use Word2vec as Vectorization and Bidirectional LSTM to classify the news. Next is research question. There are two research questions in our final project. The first is how does the use of Word2vec embedding size and window size parameters affect the news classification model, and the second is how does the use of different LSTM unit affect the news classification model. Next is the research purpose. There are two research purposes in our final project. The first is to determine the impact of Word2vec's embedding size and window size parameter on the news classification model, and the second is to determine the effect of applying different LSTM unit on the classification model. Next, research scope. Variables that we use in this research are title, content, and label. And then there is two models to be trained. The first is classification model for title. The second is classification model for content. And then there are three parameters that will be used to see the effect on classification model. The first parameter is embedding size, the second is window size, and the third is by LSTM unit. And then there are 5 evaluation metrics that will be used to measure our model. The first is accuracy, the second is recall, the third is F1 score, the first is precision, and the last is computational time. Chapter 2. This is the following part that will be described in Chapter 2. First is pre-processing analysis. Part of pre-processing analysis is data collection. Data collection is used to collect the data from a table. This is the first data set and this is the second data set. Next, data reduction. Data reduction is used to reduce the column that is not required in this research. A URL column for the first data set and a name column for the second data set. Next, data cleaning. Data cleaning is used to clean the data from null data. In this table, we can see the result of data cleaning process. Next, data transformation. Data transformation is only implemented for dataset 2 or the second dataset because the second dataset has a string label, so the string label must be transformed into the binary label. Next, data integration. Data integration is used to integrate two dataset into one dataset. In this part, we can see the result of remove duplicates after data integration is implemented. Next, punctuation and number remove. This part is required because punctuation and number don't affect the result, so punctuation and number will be removed from the data. Next, scaffolding. Scaffolding is required because there are several words that have the same meaning but are written differently, so the data will be transformed into the lower letter. Next, regular tokenization. In this part, we will transform the sentence into a token because the factorization step need input in form of token. Next, word construction. This part is required to change the abbreviated word in English into its original form, so it will generate meaningful tokens. Next, URL removal. This part is required to remove URL from the data, so it will generate meaningful tokens. Next, stopword removal. Stopword removal is required to get the core information of the news. To get the core information, any word like conjunction, personal pronoun, designative pronoun, and etc. Will be deleted from the data. Next, lemmatization. Lemmatization is required to convert a word without changing the meaning of the sentence. Lemmatization is happen if a word in the dataset is registered in the WordNet, so the word will be transformed into basic form, and if unregistered, the word will be untransformed.
The next is Word2vec analysis. Word embedding is process to converting word into a vector. Why do we need them? In general, machine learning algorithm and deep learning are difficult to analyze data input formed in string or text, so the input data must be formed in vector or number. In this research, we using CBOE architecture to vectorize the news data, where CBOE will predicting the target word probability based on context word around the target word. And this is all the parameter will be used in CBOE architecture. The first is embedding size. This is for size dimension to vectorize the news data. The second is window size. This is a space or distance between target and context word. The third is min count, to count minimum word when training the model vectorized data. The fourth is worker, to speed up the process while training model. And the fifth is iter. This is a looping process while training the model vectorized data. And the sixth is SG, to define the architecture will be used in this vectorized work. And this is the output.
Next, LSTM analysis. LSTM is made up of multiple interrelated components, including the first is forget gate. During iteration process at the same gate, each input information will be selected to determine which will be stored or rejected in the memory cell. The second is input gate. The input gate regulates the amount of input activation that enter the memory cell. The third, output gate. The output gate is responsible for regulating the flow of output from cell activation across the network. The fourth is memory cell. Memory cells serve as information transmission conduit to the rest of sequence change. BLSTM use a forward layer to learn future information and backward layer to learn previous knowledge to process input sequentially in two directions. Next, classification model. The construct model is made up of multiple levels. The embedding layers is the initial layer of the layer. The drop-up layer is the second layer. The BLSTM layer is the third layer, and the last layer is the dense layer. On TensorFlow framework, all of the layers are from Keras library with a value 64, 128, and 256 unit parameter. In BLSTM is utilized as experiment. The unit means dimension of inner cell in LSTM, because in LSTM, the dimension of inner cell, output max, hidden state should have the same dimension, therefore output dimension should be unit length as well. Next, evaluation. The following is review of the model that was used. The first is accuracy, percentage of data that was correctly classified. The second is recall, which is the proportion accurately positive, forecast to overall positive data. The third is precision, which is defined of the ratio correctly positive, forecast to overall positive project result. The fourth is F1 score, which is the average of recall and precision result. The fifth is computational time, which is referred to how long it takes a model to categorize or classify data.
Next is chapter 3. In this chapter, we will discuss about general design model and experimental design. This is the model architecture design. The first is fake news, will be enter the preprocessing stage, and the output is list of token. And this output will be entered the Word2vec CBOE stage, and the output is number of vocabulary. And enter the encode stage, and the output is vector and indicates data. In this result will be enter the main classification model using 4 layers. The first is embedding layers, the second is dropout layers, the third is BLSTM layers, and the fourth is dense layers. And after training the model, the result will be evaluated using confusion matrix, where the metric evaluation will be used is accuracy, recall, precision, F1 score, and computational time. The next is experimental design for title data. In this experiment, we built 3 models for classifying the news using different parameters for the embedding size and window size. For the embedding size, we use 100, 200, and 300 for embedding size, and for title data, we using 1, 2, and 3 for window size. And the result of this model will be saved as a Word2vec model, and then enter the classifying using different unit of BLSTM. In this stage, we using 64, 128, and 256 unit of BLSTM. and then the result will be evaluated using a conversion matrix. The next is experimental design for content data. In this experiment, we built a tree model for classifying news, and we use embedding size same as the title data. This model we using 5, 7, and 9 for Windows size. And for the unit of LSTM, same as a title data.
Next, research result. The following are the part of content that will be discussed: model result and conclusion. The following is the result of final research. The title model with Windows size 3, embedding size 200, and unit 128 produced the best accuracy result in experiment, 79.18, and the content model, the model with Windows size 5, embedding size 100, and unit 256 has the maximum accuracy, 92.80. Next, conclusion research. The following is conclusion of the final research. The first is embedding size. The vector model results are unaffected by the Word2vec embedding size parameter use. The vector that will be input to model is only affected by the embedding size. The second is Windows size. The classification model performance is affected by the Windows size 3 and 5. The third is unit LSTM. The classification model LSTM unit parameter have an impact on model performance. In addition, the number of unit in model influence the processing time. Therefore, the greater the unit, the longer the computational time.
Next, I will describe about the pre-processing implementation. In this part, we can see the library that used in this research. In this part, we can see that the first dataset is stored in DF1 and the second is stored in DF2. In this part, we can see the original size of the DF1 and DF2. In this part, we can see the detailed original form of the DF1. We can see in this part, and for the DF2, we can see in this part. The first pre-processing is data reduction. In this part, we can see there is a function that used to reduce the column. Data reduction use ilog function to take the attribute that will be required in this research. The result for the first dataset we can see in this part. And the second dataset, we can see the result in this part. Next, data cleaning. In this part, we can see there is a function that used to remove the null value. Data cleaning use is null function to sum the data null and drop null function to remove the data null. This is the result for the first dataset, and this is for the second dataset. Next, data transformation. Data transformation is needed for the second dataset, so the label of the second dataset will be transformed into 1, and label real will be transformed into 0. This is the result for the second dataset. Next, data integration. In this part, there is a function that will be used to merge two dataset. Data integration use concat function to merge two dataset, and in this part, there is a process to remove duplicates data. This is the shape of data integration result. Next, word contractions. In this part, there is a function that will be used to construct the word. The first process is we will tokenize the data, and the second is we will untokenize the data, so the data becomes one unit like this. And then we use contraction function to decipher the word. And in this part, there is no abbreviation. Next, remove URL or URL remove. In this part, there is a function that will be used to remove URL from the data. URL removal use RM module to remove the URL. And the result we can see in this part, there is no URL in this data. And this is for the title data. Next, punctuation removal. In this part, there are two functions that will be used to remove punctuation from the data. This is the looping function that will use the remove punctuation that previously defined in this part to remove punctuation in this data. This is the result for the punctuation removal. This is for content, and this is for title.
Next is scaffolding. This implementation uses Python function.lower to convert content punctuation and title punctuation into lowercase, and this is the output for content, and this is the output for title. Next is tokenization. We build tokenization function to break sentence into a token, and we use function refine all with this expression, where this expression is matched with alphanumerical character in the string, so that with this expression, every each character in the data will be checked, and if it matches a space, then a word is considered as one token. And we'll be doing this function to content news data and title news data, and this is the output for content, and this is the output for title. Next is stopword removal. In this implementation, we use library stopword and create a looping function to check every data for filtering and remove word with prefix, suffix, preposition, or article, and we create a stopword function to check and to choose the important data from the tokenization result before, and this process will be doing to content data and title data. This is the result for content data, and this is the result for title data. Next, lemmatization. In this implementation, we use word.library and we create a looping function to check every word in the sentence for normalize with this function lemmatize. And we create a lemmatize function where every word are registered on word.net library will be removed into a basic word, and this process will be doing into the content news data and title news data, and this is the output for content, and this is the output for title. And then we save all the data after applying all the pre-processing process from data reduction until lemmatization. Next is Word2vec. In this implementation, we use library Word2vec and create a function to vectorize the term, and this is the main parameter we use: embedding size for dimension for vectorized word, and workers, ithers, sg, min count, and window size, the space between context and target. And then we can save the model, and this is the result of vector for term computer, and we can search for similarity of term, and with this function we can search for similarity, and this is the output. And then we can visualization the vector, and this implementation we use matplotlib and PCA, and then we create two variable for accommodate the term and their vector, and then the vector will be reduction with PCA, and then we can use a template from matplotlib for visualize the vector, and this is the result. From the result we can see there is many cluster based on the vector.
Next, the implementation of LSTM model in the development stage is as follows. The first is count word occurrence using the update function of the counter library in collection count occurrence of its vocabulary. The second is convert word to integer. The implementation convert to number based on the number of vocabulary generated by Word2vec process by checking the vocabulary with most occurrence up to the number vocab generated by Word2vec process. Next, matrix vector Word2vec. All vectors are fed depending on the vocabulary generated by the Word2vec algorithm. Keyfold using the stratific keyfold function in sklearn library, the number of keyfolds is set to 10. Next, pet sequence. The pet sequence function in the keras library can be used to solve length equation for the data sequence, where the title data is 68 and the content is 1000. Next, the embedding, dropout, bidirectional, and dense layer make up the model layer. The unit LSTM layer parameter was utilized as an experiment. In the keras library, accuracy, recall, and precision was utilized to evaluate the model. Furthermore, using F1 score derived from the sum of recall and precision, as well as the time function for computational time. The following is a sample of the model classification and evaluation process. That's all about final project. We are from TA103 group. Say thank you for your time and your attention.